Hello everyone, welcome back to my channel. I have a quick one today. It's a fabrication video, but I've got a new camera method where it's going to be chest mounted. So let me know what you think. So today I'm going to be working on this. It's an 8-inch job, reducing down to 6-inch. Here's the fittings. Seamless pipe, pretty thick seamless. And yes, the machine. I don't know how much welding I'm going to show you, but the tacking, it's going to be a standard dip transfer route setting. So I control the amps, and then it automatically controls the volts and wire feed on its own. It optimizes the settings the best. So you can see, so 140 amps for tacking, which is 6.4 meters a minute, and 17.5 volts. The wire I'm going to be using is a, where is it? This wire here, ESAB, 1mm wire, copper free. There we go. The gas is going to be a 12% CO2 mix of argon and CO2. My mask is a Speed Glass G501. It's a all-in-one AdFlow system with the respirator right here, with filters, keep my lungs all nice and fresh. So yeah, I'm just gonna put the mount on now and run through what I'm gonna do. I'm probably gonna tack this together, weld this up, put this elbow on my captain's wheel here, and then run here and here. A quick one, I am going to be tacking onto this pipe, so I get a few comments, people confused. This here is all low pressure, no more than 6 working bar. Yes, I'm sure it's not ideal where you're from, but where I am here making this pipe here, it is more than acceptable. So just understand the limitations of your job, and if you can and can't do it, and the limitations of my job.
So guys, I'm hoping in this video I can be as precise as possible and show almost every step needed to learn on your own and become proficient at pipe fitting. Because when you break it down, it's not hard. It is really not hard. It's just knowing the correct things to do. And hopefully this video can speed run your training when it comes to learning how to pipe fit. Because it's just a series of things together, such as this piece here, this elbow. I've gotten to the point now, I know what size gap I like. I either use a spacer or usually my eye get the gap in. I use the table because the table's a consistent flat edge. Yes, you may get a little bit of a misalignment of the pipe, but it's so minor that something like this is fine. What you see me do just there, I tacked the inside of the pipe. Because I'm trying to make my welds seamless the whole way round, if you tack on the inside, then you know you can grind and feather the outside as much as possible, and you've still got a nice meaty chunk of weld holding the pieces together. The alternative is cutting your tacks out. Now if you're in a place where you need to cut them out, but this work that I'm doing here, it's only class 2, so there's certain levels of discrepancies that, you know, you can have minor defects like that. It's only for chilled water, no more than 6 bar working pressure, so it is really minimal. So the 4 tacks have gone onto the elbow. For time's sake, I'm adding this little extra pipe here. Usually it's not needed for something like this because I can add it at the next step. But because it's small, it's not going to affect the handling of this pipe. And the more you can get done at each individual stage, the less you have to do next. And yeah, it just speeds up the fabrication. Because the way how I get paid, I'm on price work. So every size weld you do and type of weld, fillet, butt, shoe, socket, everything has its own price, and it changes for each size. So I'm in the habit of getting work done as fast as possible so I get paid. And that's why you're going to see certain fabrication techniques that, yes, I wish I could do it another way, but it might be a little bit easier, but it might take a lot longer compared to how I'm doing. So yeah, my all my techniques are with speed in mind first, but I'm not going to be doing anything silly to, you know, to do silly cutting corners for the sake of speed. But here's a prime example. Marking up the socket locations right here. I could put it in the vise and I could have it sticking up in the air, but that's extra steps when I can have it here right now. I used a square because the pipes on the table flat. I can mark it out sideways. Use the square now.
What's happening?
I'm here for that protractor. Muchas gracias, señor.
No worries.
So back to what I was saying. Yeah, I could use the square to scratch it. It's 90 degrees to the pipe, which is to the table, everything's square, and to scratch it on. It's marked now, and I've not had to double handle, I've not had to put it in the vise to mark it. I'm getting it done out of the way first. Sockets are a little bit of an exception. Sockets are annoying. They yeah, I hate doing sockets. So sometimes you can't always make it efficient when it comes to installing your sockets. You just make do. They demand their own special attention. So this case here, cutting it and putting it on sideways is what I did, because for one, I did not want to mess around with it later on in the job when you're tired and then you think you're done and you're like, oh damn, I got to re-square it to put a socket on. Yeah, it's just easy this way. I plasma cut the hole. I tried to have a gap. Yes, I am hitting it with my my torch. Leave me alone. What can I say? I'm using a square, and again, I'm hitting it with the hammer. Bear in mind, there's only one tack on it, so I am not damaging the socket hitting it with the hammer at this point here with only one tack on it. Yes, later on it's got two tacks on it and I hit it, but I have a loose grip in my hand and I try to hit it with a as square on as possible, and I know how hard I can hit it before it starts to distort it, and I always try to hit lower down anyway. Again, it's just one of them things. You could say I should screw some pipe in there and hit it that way, but I'm not going to do that. I have to put so much sockets on, and when I tell you, I get paid almost nothing to put a socket on. So it is what it is. What can I say? 2 tacks on, and then the final 2 tacks. For the most part, this is level enough. Yes, it's only going to be, you know, like pressure gauges, temperature sensors, the odd pigtail going in these things. It really is nothing that special. It's not for oil. It's for chilled water, for usually data centers or plant rooms, you know, for commercial building spaces. It is nothing high tech, high pressure. Here you see me using the spider clamp. I usually use a V stand, but today I was feeling extra lazy and I grabbed out the spider clamp. It's one of them things. I tend not to use a spider clamp because I'm always trying to learn and you know, be more proficient, and any type of things to make my job easier I can appreciate, but something like this takes the skill out of it a little bit. So yeah, I rather just hang it with a V stand or another way than use that. It's a little bit cheating, to be honest. In general, all pipework is fabricated with 2-hole top. So that means on all of the flanges, there's normally 2 holes at the very top, and that allows you to keep uniformity across the whole system. And you know, where it's 2 holes, you can, depending on the type of arrangement, you can flip the pieces 90 degrees to each other, so nothing's ever out of whack. And yeah, you can see me the 2 holes on top with the bolts, and then the face of the flange is level to the length of pipe. Flipping it vertical up now, it is easier that way because the sockets are in the way. It's easier just to, you know, stick it up, put the flange on the face of the flange. Put the level on the face of the flange, and then one vertical on it. Again, I've not done anything that is really special. It's just, if you've not seen this being done before, it doesn't quite come naturally to you. But having watched this video now, I'm not I'm not doing anything particularly special. It's just you know, the techniques that you pick up from people that can help speed up and make it easier for you. The tacks that I'm doing, pretty big tacks. I like to feather them down. In this, I never quite caught the edges of the tacks. Again, I try to avoid that, but it happens. That's the discrepancy that is allowable. But me as a welder, I'm always trying to do the best weld as possible. So feathering the tacks, I always try to feather them away. The fact that they don't always disappear, it kind of makes me question my ability sometimes. But if I was to do a weld test and have to cut them out, I can cut them out and have flawless welds all the way around. Here's a little tip, a little faster fabrication technique. You can see I put 2 bolt holes in the face of the flange, used it to level the flange to the edge of the table. I like working with things more square, and then I use a square on the face of the T to try to line up the bolt holes. Depending on your accuracy, you can get it within 90% to 100% each time. If it's not perfect, you really won't see. It is not that bad, but it just saves time. Alternative would be, I don't know, putting it in the vise, having it stood upwards on the table and bringing a V-stand in. It's just a whole bunch of extra handling. Bear in mind, this here is 8-inch pipe as well, so it is heavy. You know, I don't like lugging it around. I can't just chuck it around like it's a small piece of pipe either. So anything to make my job easier. 2 tacks in, and now just leveling it off the second orientation. People complain and say, oh, you're gonna get arc burns on your flanges, on the face of your flanges. Watch how many times in this video I clean my levels off and I brush things off to get rid of any of the grinding dust. This doesn't give me arc burns. My table is always cleaned, it's always brushed, the faces of the flanges are always cleaned, and if you tell me you're going to get arc marks from 2 clean surfaces, yeah, you're lying. You're just commenting for the sake of commenting. I'm about to do some welding soon, and I believe I'm probably just going to leave it for you lot to listen to the audio. I won't talk over it, so I'll do a bit of explaining beforehand. The welding process that I'm doing, it is a short circuit dip transfer route and a pulse cap. Sometimes you can do a hot pass, you don't always need to, but essentially when the wire touches the material, it short circuits, deposits a bit of material, and it happens, I think, hundreds of times a second, or just a silly amount. The capping is pulse. It is a type of spray transfer with a digital sine wave, which allows you to deposit the material onto the workpiece without it having to touch. So there is no short circuit. It minimizes any spatter. So done properly, there is no spatter, and the material can be deposited out of position. So when you're doing pipe, you don't need to be at 12 o'clock for the material to deposit, as well as leave a nice cap profile. It is a game changer for pipe welding, and any of you who have never seen MIG root and caps before, you're going to be surprised. So just enjoy, and yeah, just let me know what you think in the comments. So that there is what I would call stage 1 welding completed. Jobs sometimes take multiple stages of welding to get done, such as the T. No matter what you do, if there's a T, you tend to have to weld the piece on that I've done there first to then be able to roll the other two sides. So I'd call that stage 1. So stage 1 of welding is completed. Hopefully it's only 1 or 2 stages per job. Some jobs there are a couple of stages of welding, and they drive you crazy because now you're working with hot pieces, and it is not nice to be trying to fit up to a piece of pipe that's just been welded, such is the case here. Anyhow, vertical up is the easiest way to fabricate any type of pipe. You know, you clamp in or level off the piece at the bottom, and then you add a piece on top and level it off to it. That's the easiest way. That's what I've done here for the reducer. I chuck the level on just for the sake of it. You really don't need it sometimes. Most times it is, you know, the discrepancy of the level of the cut compared to the gap that you have, it's not that bad. Sometimes it's worth just going with a nice gap that you like to work with, and whatever the level is not going to be thrown off that much for it to be an issue. I could have fabricated this on V stands. Again, it's longer. On my vise doesn't open up to 8 inches, so the table is the best alternative and the easiest. Look at this now. The T is there, leveled off. I know the length of, I know how level my table is, so then I know what the T face should be. So from running from back to front of my table, it's level. Running from left to right of my table, my table touches the left side of the level. So I still put the level on top of the face of the flange, but just to double check. But it's just easy on the table, one time. Nothing can really go wrong. Even this stage here, flipped it to the side, and just transferring marks over what the bolt holes is to the top of the elbow. It isn't really that hard. I've still not done anything that's special. It's just the techniques that I use make it easy for me. But if you follow these steps making your own pipe, it's nothing special, if that makes sense. Or maybe I'm talking out my arse and I don't really realize how difficult it is because I've been doing it 11 years now. I'd like to think that I'm not doing anything special, and anyone can do this given the right information. 4 tacks is all you really need on these. Some people are adamant, you know, you have to go around, do more tacks, it pulls. MIG welding, it does not really pull too much. Even on flanges, even when I do 16, 18 inch flanges and stuff, in general I just do four tacks and it is more than enough. But what I do with my tacks is I move distance. I don't stand still. I find when you stand still, you get a crater and a crack. So I always tend to walk my tacks, make them horizontally long, at least 10-15 mil, and you can't go wrong. This little tip here, you know, I was using no V stand, so I kind of put a temporary baby tack just to hold it in place, opened up my gap at the bottom, and then cut the gap at top. Save me grabbing any V stand, save me having a helper hold it, save me doing a whole bunch of longness where, you know, it's just taking longer than it needs to be. Please let me know in the comments what you think about this type of video. So what's different with this video obviously is the first person view, but also it's a lot longer. I believe it's like nearly 30 minutes long. I tend to make my videos up to 10-15 minutes long, only because of the retention. Honestly, as much as some of you may enjoy this, the YouTube tells me that I get average view duration of like 2.5-3 minutes per video, stuff like that. So I tend not to do such long videos, but please let me know in the comments. Maybe I'll bring back this first person view. It's interesting to see, but it does, the videos are definitely slower paced this way round, and I find, because I'm using my phone to record on my chest as well, I find it's a little bit too zoomed in. I think now I'm using the fisheye lens, you know, where it's zoomed out a little bit more, but at the start of the video I think it was, you know, it's a bit too zoomed in. It restricts your view, but it's still something that I can persevere. It is something that I can continue to do if you lot enjoy this. I can't even get my words out today. Even two flanges hanging off the table, I'm able to get a tack on it and get a level on it. There is a lot you can do on the table. Occasionally it is longer on the table, but for the most part, the fact that things are almost instantly level can save you a bunch of time. Now I'm just calculating. So the overall is 477 mil plus 391 to get the overall, minus 110 to is the half the diameter of the 8-inch. So that's 758, I believe, should be from the edge or the inside of the elbow to the face of the flange. I don't like it when it's shorter. If it's a little bit longer, it's fine because it can shrink. So off camera, I think I measured it, or no, that was it. So what happens, you work by autopilot. I believe I'm a little bit dyslexic, I'm not too sure, but I see a number, I read the number, I confirm the number, I weld it, and then a few minutes later, when I went to, you know, check it later on, I don't know why, I made a mistake. I was meant to cut off 9 mil. Correct myself, I was meant to cut off 40 mil. And even when I done the chop list, I calculated only 9 mil to be chopped off. And then when I checked it, it all made sense. And only once I finished welding it did I realize I went and done something wrong. So I went and actually sat down and calculated it again to realize 40 mil needed to come off. You work on autopilot, or I work on autopilot so much that easy mistakes happen like that, and I don't even know how. You know, from doing a lot of video editing, I can see the amount of mistakes I get with numbers, where I see one number and say something completely different. My brain and mouth just, they ain't connected properly some days. But I was able to chop it on the saw, re-weld it, and yeah, this is the final. So this will be stage 3 of fabricating welding. First stage is the elbow, the piece of pipe, and the flange. The other stage is the T and the flange, and then stage 3 would be the two ends on the T, and now this here is a final step. You know, multiple stages of welding. But I like to do it this way here, because at the end you want to be just done. I don't want to be doing a whole bunch of welding, so split it up. Nothing hard. And again, the captain's wheel is the turning bar that I use. I don't always end up putting it on level, so there's times where I have to fiddle around for ages to try to get things somewhat level, and yeah, it's a nightmare sometimes. But this case here, I don't think it was too much fiddling about. There's times I have to lift up my table just to, you know, get the pipe level. But this time, yeah, it weren't too hard. Got the 2 tacks on it, leveling everything off, and yeah, it's just we're coming to the end. We are coming to the end. This was a long pipe to make, as well as filming it takes a lot longer too. So I get a little bit of anxiety when I feel like I'm taking too long. Again, I'm on price work, so my whole life is my whole wages and life is determined on how fast I can work. So when I feel like I'm having delays, I'm just, you know, inside of myself, I'm just boiling up thinking, oh no, I ain't making money today. This is long. Why did I even do it this way? And, you know, you just start panicking a little bit, just because it's literally linked to your earnings. But the job is done. This was a monumental effort, but nothing special. A couple hours work. I think I give a outro in this video, so I'm going to stop talking here. So thank you very much for watching, and subscribe if you liked what you see, and I'll see you lot in the next one.
So it is done now. It took a long time. It took around 3 hours to do, which in my books, three and a half hours in my books is it dragged. Oh, it dragged. But it's finished. What I'd done, somehow I'd accidentally mixed up these pieces. So I cut closer to the T, which obviously makes it look a little bit silly, but you know, I was able to weld it. I cut it closer to the T so I can grab a fresh elbow. Here's the old one. I didn't want to cut that up. That can go in the scrap, to be honest. That's how things like this become consumables in this place. It's that big. So yeah, I grabbed the fresh elbow, got the measurement. I could only assume that the center of this to the center of that needs to be a specific height. Here's the root. Again, it is not the best. You can see my tie-ins. My tie-ins aren't the best because I feather them down, so I need to maintain a certain amount of strength while being able to, you know, mostly weld over it. But as you can see, it's a little bit dodgy there. It's just the tie-ins that are bad, but it's a class 2 job. It's a class 2 job, root penetration and defects and stuff like that. It is more than adequate for this job. If I was doing x-ray, then I would not leave the tacks in. That's as simple as that. I'm on price work, so I'm trying to weld up this pipe as fast as possible so I can get paid as fast as possible. Once the piece is done, I'll clean the inside of these after. But this is how it's come out. It's a decently big piece. Now I'm gonna go home. So yeah, that is the job finished. Thank you very much for watching, and I will see you lot in the next video.